Are we on?
Yeah.
No, there's no check.
Are we recording? It says we are. We'll trust it. Okay, well, here we go. So, hello and good day, by the way. Today in Algebra, we're going over CO6, writing, interpreting, and evaluating algebraic expressions. So, this term algebraic expression is kind of what we're going to focus on, defining, first of all. What is an algebraic expression? Or just as it says here, what's an expression? Not a facial expression. We can't see those anyway, but yes.
It's basically an equation.
It's actually, it's not an equation. And the difference between an expression and an equation is that an equation shows value. It has an equal sign in it. An expression is just like an equation, but without the equal sign. Okay. And so what it is, it's essentially a mathematical statement. Okay, a mathematical statement. So if we have something like 6 plus 3, that's just a statement. We haven't given it value. We don't know what it equals. I mean, we do, but it's not written there. That would be an expression. As soon as we add an equal sign and we say 6 plus 3 equals 9, now it becomes an equation because we've assigned it a value. Okay. How about a variable? Definition of a variable. Definition of a variable. Daniel.
A letter.
Usually a letter, correct. Thumper?
No.
What? No? No, you don't know. Okay. Yeah.
Maybe like a thing that goes in place of a number that you do not know.
Right. It's a letter or symbol that goes in place of a number that you don't know. In an expression or an equation, it's an unknown value. We'll kind of simplify that definition to be an unknown value. Okay. Usually, it's represented by the letters X or Y or Z or N, but it really could be anything. Okay. It really could be represented with that. In area formulas, it's B and H, right? Or L, W, H, right? It's just, it stands for an unknown value or a value that can change. In science, when you do experiments, you talk about variables perhaps, okay? Things that you can't control, that can change, that you're testing, right? There's that relationship there. Yes?
For the test, like the help sheet, what can you add in the help sheet?
So help sheets for a test can have either the wise old owls, okay? They can have key points. So the table that we're going to fill out today can go on a help sheet. And then they can have these, cautionary symbols here, just brief reminders not to do something, or this is a common mistake that folks can make. They can't have any worked out examples. So anything that's under the Mr. Happy Pencil section or the real world, the happy little globe guy, can't have any of that stuff. Okay? Yes.
We have as many pages as we want.
Yes, you can have it on one little note card or several loose leaf pages. The only thing, you can't, this has happened before where someone will go through the trouble of making their own help sheet and then they copy it for a friend to use. What you use must be your own work. Okay, you need to make your own help sheet. All right. So what we're going to do today is we're going to kind of tackle the issue of word problems in math, because oftentimes I would even venture to say, folks think that the word problems are very challenging because not sure what to do, what information is important, what does this mean, what does that mean. So we're going to focus on representing each of the four major operations with words or phrases that you might see in a real world or a word problem example. So going at any of them, addition, subtraction, multiplication, or division, give me a word or phrase that represents one of those operations. Yes? Quotient falls under division. Yep, good. And if you want kind of a hint, I recommend looking down the page a little bit. I've got several mathematical statements there. If you see something that pops out at you that you think might belong in one of these. Brent? Sum goes under addition. S-U-M is how you spell the addition sum. Thumper? Times under multiplication. Good. Daniel.
Oh. Under multiplication.
Oh, of, sorry. Yeah, and the word of is oftentimes preceded by the word groups, okay? Groups of. The other phrase, the other operation that uses the word groups would be division, and you'll see it with into groups, okay? Into groups. So groups can be either multiplying or dividing, kind of comes what's before or after, but good. Olivia.
Minus
Subtraction, minus. Brady.
Difference, subtraction.
Difference for subtraction. And there's two more I want to mention specifically for subtraction. So I'm going to go there now. You can put your hands down for just a moment. The phrase less than and the phrase subtracted by versus from. Okay, subtracted by versus subtracted from. I'm going to put those in there and then star them. Whoops. Unless I drop everything. Okay. If I put a subtraction expression up on the board here, 10 minus 8, okay, does that say the same thing as if I said 10 less than 8? Does that 10 minus 8 represent 10 less than 8?
No.
It doesn't. Okay. When you have 10 less than 8, that means you're starting with 8 and you're taking 10 less than that. The order is actually different than what you see when using that phrase less than. So 10 less than 8 would actually be 8 minus 10, which is a different answer than 10 minus 8. Okay? We see something similar with subtracted by versus subtracted from. This right here could be said using 10 subtracted by 8. Right? 10 subtracted by 8. We're starting at 10, and then that is subtracted by 8. However, if I said 10 subtracted from 8, what does that translate to? 10 subtracted from 8. Brady?
10 minus 8.
Not if I say subtracted from.
Minus 10.
8 minus 10, yeah. So the phrases less than and subtracted from, the order switches from how they're written. However, subtracted by is going to stay the same. So you really got to think about, what is this telling me? What is this really saying? Okay, which again speaks to why word problems can be some of the more challenging things that we do in math. Okay, but back to it. Additions, multiplication, division. What else? Yes. The word and is kind of more of a connecting word because you can say like the product of 5 and 10, and that would still mean that you're multiplying, or divide 20 and 4, So the word and is kind of, there are more exceptions than not. Demonso. Products, multiplication. Others. Gabby. Divided by and division. Brady?
Half the difference.
Ooh. So half the difference, which part of that? Because difference we know is subtraction.
Yeah.
So half, okay? Or take a third of something or a quarter of something. Half divided by 2, third divided by 3, quarter divided by 4. Poor addition there. We're just not getting any love over there. What other words mean addition? Bridget? Plus, sure. Total might be another one. Okay? I think that pretty much is everything. Yeah? Added to. Probably be the grammatically correct way to say it. Added to. One more for multiplication just to fill it out.
For addition,
More than, sure. Yep. Put that in there. Okay. For multiplication, if you have twice, something, that would mean multiply by 2, triple, multiply by 3. Okay, good. I like this list. And so your job today is to go first from the verbal to the numerical, and then on the second page, go from the numerical to the verbal. Okay, so looking at what you'll be tasked to do here, this first page says, write the verbal phrase as an expression. Evaluate when n equals 2. So let's just look at the first one. The quotient of 16 and a number. We see the word quotient, which refers to the operation of division. So then we say, well, what are we dividing? 16 and a number. This phrase, a number, is what we would say is a variable, right? So how can we write the quotient of 16 and a number? How do you want to write that? Gabby? 16 divided by n. And you can write that horizontally. You can write it vertically as a fraction. Either way is fine. Okay? Either way is fine. Once you write it, though, you then need to evaluate that expression when n equals 2. So in 16 divided by n, if n is 2, what's the value of that? 16 divided by n becomes 16 divided by 2. I heard someone say 8, and that is correct. Okay. The one right below it, I want to give this one some attention here. 12 times a number, comma, minus 3. Okay, that comma is actually very important, because if I just say, write 12 times a number minus 3. 12 times a number minus 3. Does he mean 12 times a number and then the minus 3 is after the product? Or does he mean 12 times a number minus 3? Whoops, not 31, right? Two different expressions here. Those parentheses, like we talked about in PO5, they change the order in which you would solve this. So that comma, which in a sentence is like where you would pause, you would read that as 12 times a number minus 3. Which one does that refer to, the top or the bottom? 12 times a number minus 3. The top one, right? That pause kind of separates that product from the subtraction. Whereas if I just say it 12 times a number minus 3, well, that doesn't really give you a whole lot of hints as to what I'm talking about, okay? So pay attention to commas, because they do a good job of separating those operations. Evaluate when n is 2. So if n is 2, becomes 12 times 2 minus 3, 24 minus 3, 21. Okay. Another one on this page you want to talk about before we go on to the second page? Daniel? All right, 17 less than the product of a number and 9. So here we have that phrase less than, okay, which we know means subtraction, but we start it in our table because we want to pay attention to the order here. 17 less than the product. Product means we're multiplying. The product of a number and 9. Anyone want to take a guess at how we would write this as an expression? 17 less than the product of a number and 9. Thumper.
9n in parentheses minus 17.
What's in parentheses?
9n.
Okay, so he's saying 9n minus 17. He suggested putting parentheses around the 9n. Do we have to? No, because we're multiplying anyway, which comes before the minus 17. Would it be wrong to? No, but they're not necessary. This is perfect. Okay, 9n minus 17. We are taking 17 less than the product of whatever 9 and n is. Okay, when we substitute n to be 2, we're taking 17 less than the product of 9 and 2, or 17 less than 18, which equals 1. Okay, well done. Well done. All right, anything else with the front page? Okay, second page, now you go the other way. We are going from the expression to the verbal, and again, you do need to evaluate this time when n equals 10. So pick one you'd like to talk about. We've got several to choose from here. I know it. Kylie?
The very last one.
How did I know? So we have in parentheses 43 minus n, then divided by in parentheses 5 plus 6. Whew. Okay. Going to the verbal, you've got some options here, right? Any of the phrases that we use in that chart up above can work here. Yeah, go ahead.
Are we evaluating the equation and then writing it, or are we like
It doesn't matter which one you do first.
number? Are we using n as a number, or are we using n as its value?
Good question. Thank you. Use n as the number. So when you're writing this out, instead of 43 minus 10, say 43 minus a number. Okay. But give me some options here for writing this one out verbally. 2 sets of parentheses. We got 3 operations going on. Brent, what do you think?
43 minus a number divided by the sum of 5 and 6.
Okay, so we have 43 minus a number. You said divided by the sum of 5, almost made it, and 6. So if I read that the way it's written, I could make a case that what you're saying is 43 minus a number divided by the sum of 5 and 6. What could we add to Brent's statement that would kind of bring it home and give us what we have here? Thumper? Where? Not after divided by. After number. Well, what we want to kind of group together here is that 43 minus a number, right? Now it says 43 minus a number, there's a break, divided by the sum of 5 and 6. So that's what this would say here. You could also write that as 43 minus a number divided by the sum of 5 and 6. That would work as well, writing it vertically. Okay. If you didn't want to use a comma, if you're anti-comma, you might say the difference of 43 and a number divided by the sum of 5 and 6. That would also work, and you wouldn't need any commas. But now you would evaluate that when n is 10. Any other from this page? Any others? Yeah? 2 plus n divided by 3. Any thoughts? Elise?
The sum of 2 plus a number
The sum of 2 plus a number divided by 3. What makes this challenging is that these verbal phrases can really be open to interpretation. Could I make a case that what this says is the sum of 2 plus a number divided by 3? So again here, and you'll see this often when you've got multiple operations going on, what would we need to add and where? To make this very clearly, no, you're taking the sum first and then dividing by 3. Elise, you want to fix it?
maybe the quotient of the sum of 2.
Okay, so yeah, we could say the quotient of the sum of 2 and a number. Well, we still probably might want this there but where could we add a comma? Julia, not everywhere. That's not Julia. Right. The sum of 2 plus a number, comma, that separates it. Then what do you do with that? Then you divide it by 3. Okay? So 2 plus n, comma, divided by 3. And then, of course, you would evaluate when n is 10. So 2 plus 10 is 12 divided by 3. The value of this is 4. Okay? Then the part at the bottom, we've got a plan for an allowance down here. Okay? back in my day, if I wanted an allowance, I had to do chores first. But it says your parents will give you $1 more than double last month's allowance. $1 more than double last month's allowance. Think about what that's going to look like as you go through the calendar here. I think that if you do this correctly, you'll find that you'd be very happy with that particular plan.
Yeah.
$1 more than double last month's allowance. But once you do that, you then need to write an expression that models how your allowance increases from 1 month to the next. You'll notice, if you're paying close attention, your binder has weeks here rather than months. A 7th grader pointed that out to me. I fixed it here so that future generations of algebra takers will not be confused, but obviously I printed these binders before I fixed it. So yours says weeks, but it should say months. It should say months. Okay. Your homework is to finish CO6, both the front and the back. We'll go over it tomorrow along with your math packet. And that, folks, is how you math.